welcome to True Projects. In this video, we are going to explain about the project title Cyber Threat Detection using NLP and Machine Learning. Before diving into the execution, let me give you an overview of the project. A cyber threat is any malicious act aiming to damage, steal, or disrupt digital systems, including hacking, phishing, malware, and DOS attacks. Cyber threat detection involves using technologies to identify and respond to security threats, enabling early identification, impact mitigation, and future incident prevention. Traditional cyber threat detection include signature-based detection, anomaly-based detection, and rule-based systems. These methods struggle with new threats, have false positive rates, limited scalability, and rely on frequent updates and expert intervention. The proposed system utilizes NLP and machine learning algorithms like Navy-based SVM, support vector machine, KNN, K nearest neighbor, random forest, bagging classifier, boosting classifier, neural networks, and voting classifier for cyber threat detection. It gathers and pre-processes data, trains models with cross-validation, and deploys the most effective ones in the detection system, updated to counter emerging threats. The project benefits cybersecurity professionals, organizations, businesses, and end users by enhancing threat detection, protecting data, minimizing financial losses, and ensuring overall digital safety and security. Flask, a lightweight web framework in Python, is integrated to deploy the cyber threat detection system as a web application. This enables easy access and interaction with the system through a web browser, facilitating user-friendly management and monitoring of cyber threats. To implement this project, we need software and hardware requirements. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project for cyber threat detection. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here the random forest outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations, such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here, this is the data set. Let us open this. So in this project, we have utilized the annotated data set. So here, these are the parameters, ID, text, and here we have the annotations. And here, this is the target column in which we have the types for cyber threat detection. So this data set is used to train the models. Now let us close this data set. And here, this is the sample text document So in this, we have the test cases which we will use during the execution. Now let us close this. Now, first we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered. So click on login link here. So here we need to enter the username and the password, which are static, and then click on login button. We have logged in successfully and we are redirected to the prediction page. So here we have the text box. So here we need to enter the text, and after entering the text, the application will detect whether cyber threat is detected or not. So from the test cases, which I have showed you during the explanation of the code folder, which are these, I am copying the first one and paste it here. So this is the text which we have entered. Now click on submit button. So here we can see the result, that is cyber threat detected. Based on the text provided, cyber threat is detected. Now click on try again. Let us enter some more text again from the test cases itself. So here I am selecting this text and paste it here. So this is the text which we have entered. Now click on submit button. So here we can see the result, that is safe message. So the message which we have entered is a safe message and it is not detected as cyber threat. Now click on try again. Let us enter some more messages again from the test cases itself. So here I'm selecting the second message, copy this and paste it here in the text box. So here this is the message which we have entered. Now click on submit button. We need to wait for a little bit. So here we can see the result, that is cyber threat detected. So based on the text provided, cyber threat is detected. Now click on try again. Let us enter one more text from the test cases itself. So here I'm selecting the second text, copy this and paste it here in the text box and then click on submit button. So here we can see the result, that is safe message. So the message which we have entered is a safe message and is not detected as cyber threat. In this way, just by entering the message, we can detect whether the message is safe or cyber threat. Detecting cyber threats early is beneficial as it allows for prompt mitigation, minimizing damage and disruption. Early detection reduces the risk of data loss, financial harm, and reputational damage, while also facilitating the tracing of threat sources and implementation of preventive measures for future protection. Now click on About button here. So here we have the word cloud, which shows the most repeated words in the data set. So here we can see the most repeated words, which are ransomware, cryptocurrency replacing best scams. And here, this is the bar graph representing different labels. On the x-axis, we have the annotation, which are irrelevant, business, threat, and unknown. And on the y-axis, we have the count for the annotation. And here we have the comparison graphs for all the algorithms. On the x-axis, we have the algorithm name, and on the y-axis, we have the score for the evaluation metrics: accuracy, precision, recall, and FN score. So here, accuracy is represented with blue color, recall is represented with orange color, precision is represented with green color, and FN is represented with red color. And here we have the individual comparison graphs also for different evaluation metrics: accuracy, recall, precision, and FN score. So the algorithm which is performing best in all the evaluation metrics will be used for prediction. Now click on logout button here. So in this project, we have developed a system where we enter the text, and after entering the text, the application will detect whether cyber threat is detected or not. And we have utilized various machine learning algorithms in which the random forest outperformed the other algorithms, and that is the reason we have deployed it in the front end. Detecting cyber threat early is very important.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.